Welcome to the presentation from Elias Stathatos. He is the CTO at Brite Solar Technologies, and today he will talk about their piezoelectric drop-on-demand inkjet printing as a high-throughput technique for fabricating large-sized perovskite solar modules. Elias, over to you. The stage is yours.
Thank you very much, Christoph. It is my great pleasure just to accept this invitation just to present some of our recent developments on perovskite solar modules, basically made with piezoelectric drop-on-demand inkjet printing technique as it appears to the screen now. First, some of a short introduction of who we are. Brite Solar is a nanomaterials company founded in 2009. The company utilizes innovative materials and deposition techniques, basically inkjet printing, to deliver a new class of glass materials for building construction and recently for greenhouses also. The basic fields of research and development of Brite Solar are first the emerging solar cell technologies like Dyson-style solar cells. Initially, we were employed with this technology, and then we skip it to perovskite solar cells. Secondly, we have applications such as electrochromic cells, commonly known as smart windows. This is when we apply a small bias and change the color of a glass pane. And finally, with luminescent solar concentrators, where we utilize UV solar light and shift it to visible light. And as a result, we increase the efficiency of solar devices such as silicon-based photovoltaics, and also to the power. I mean to this kind of for the plants, the power. A short overview of this presentation is first a short introduction to perovskite solar cells, basically to the carbon-based whole transport material-free perovskite solar cells, which are always, we use ambient air conditions just to process all the materials and the devices. Then we move to the scaling up of perovskite solar cells, basically using inkjet printing method. Third, we present the Brite's research and development on ambient air processed carbon-based whole transporting material-free perovskite solar cells in terms of their performance, stability, and scaling up. And finally, we will conclude with some of our future plans. A very short introduction to perovskite solar cells, basically not the technical part, but from the part of the market. So a perovskite solar cell includes always a perovskite structured compound. Most commonly, it is a hybrid organic and inorganic lead or sometimes thin halide-based material as the light harvesting active layer because it absorbs most of the visible light. Perovskite solar cells are considered the most exciting and blooming technology for research and development, given the extraordinary optoelectronic properties of perovskite materials and voluminous optimization through device engineering. The global perovskite solar cell market size was valued at $0.4 billion in 2020, and it is forecasted to reach $6.6 billion by 2030. Growing at a compound annual growth rate of 32.4%, which is incredible from 2021 to 2030. Europe is, however, anticipated to grow at a significant pace over the forecast period in the perovskite solar cells market, attributed